Galvanic cells that involve the following pairs of half reactions are constructed. Write the net ionic equation and determine the standard cell potential for each galvanic cell. We have two half reactions here. O2 plus 2H2O plus 4 electrons is going to give you 4 OH minus. Al3 plus 3 electrons is going to give me Al. So with these two half reactions, the first thing I need to do, I need to go and use the standard reduction potential table and find out these half reactions there. I can see the first one. When I find it, it says it's 0.40 volts. That's the standard reduction potential. And for the second reaction, we have Al3 plus 3 electrons is going to be Al. That's going to be negative 1.66 volt. So then, if I want to find out the standard cell potential, that's going to be equal to standard reduction potential of the cathode minus standard reduction potential of anode. Cathode is where reduction happens. Anode is where oxidation happens. Reduction happens where we are dealing with a stronger oxidizing agent. How do you figure out which one is this stronger? We need to find out which one is greater. So here we have plus 0.4, here you have negative 1.66. So since this one is bigger, it means that the first reaction is going to be reduction and the second reaction is going to be oxidation. So that's going to be 0.4 minus negative 1.66. That will make it as 0.4 plus 1.66, and that's going to be 2.06 volts. Now for writing net ionic equation, the first reaction is reduction, so I need to keep it like that. But the second reaction, I need to write it the other way around in order to be able to cancel these two reactions. So we have Al gives us Al 3 plus 3 electrons. Here we have 4 electrons, here we have 3 electrons. So I multiply this one by 4 and multiply this one by 3. So it's going to be 3O2 plus 6H2O plus 12 electron. It's going to give me 12 OH, and here we have 4 aluminum gives us 4 aluminum 3 plus 12 electrons. When you add these two cancel out, and we have 3 oxygen plus 6 water plus 4 aluminum, and this side we have 4 aluminum plus 12 OH minus. That's going to be the net ionic equation. And as you see here, that's totally balanced as well.